Late Ordovician. 445 million years ago, the world looked nothing like it does today. There were no trees, no flowers, not even a blade of grass on land. Almost all of life was packed into the oceans, being one of the richest times for sea life the planet had ever seen. The seafloor was covered in creatures that looked almost alien. There were small armored bugs that crawled along the bottom and giant shells which were relatives of squids, some stretching several meters long, floating through the water. Coral reefs were forming for some of the first times ever, and everything seemed to be moving forward. However, the climate was quietly setting a trap. For a long stretch of time, Earth had been warm, and that warmth kept the oceans full of life. Then, slowly, temperatures began to drop. A large landmass sitting near the South Pole started to grow thick sheets of ice. As more and more water froze into these ice sheets, sea levels around the whole planet began to fall. This is where things got dangerous. Many of these ocean creatures depended on shallow coastal waters to live, and as the water pulled back, those shallow zones shrank or disappeared completely. Species that had thrived for millions of years suddenly had nowhere to go. Then, after the cold peaked and species were beginning to get comfortable once again, something weird happened. The ice began to melt once more, and sea levels rose back up. As the ice melted, it likely changed ocean chemistry and reduced the oxygen in the water in certain areas. Two disasters, one right after the other. Because of this double blow, close to 85% of all species living in the oceans at the time were wiped out. It stands as the second most severe extinction Earth has ever experienced. What makes the late Ordovician extinction different is that it did not come from something dramatic like an asteroid or a giant explosion, unlike some of the other ones we'll see. Late Devonian. 370 million years ago, Earth was finally starting to feel more familiar as life had made a huge leap. Plants covered the land, some growing into real trees for the first time, forming the very first forests. However, the real action was still happening in the water. The oceans and coastlines were bursting with more types of fish than had ever existed before, so much so that many people call this time the Age of Fishes. Reefs were massive, some of the largest Earth has ever built, and swimming around them were armored fish covered in thick bony plates as if they had a natural armor and helmet. Some of them grew to be enormous. Alongside them were early sharks and countless smaller fish. However, something was quietly setting off a chain reaction. As forests spread across the continents, their roots broke down rock and soil in ways that hadn't happened before on such a large scale. This process pulled large amounts of nutrients into rivers, which then carried them into the oceans. At first, this might sound like a good thing. More nutrients usually means more food, but too much of it caused a problem. All those extra nutrients caused massive blooms of algae in the water. These algae blooms used up huge amounts of oxygen in the water as they grew and then died and decomposed. As oxygen disappeared from large parts of the ocean, the other creatures there began to suffocate. This chain reaction stretched out over a period of nearly 20 million years. Reef systems that had taken millions of years to build were hit especially hard, and many of the coral and sponge-like organisms that built these reefs disappeared and never came back in the same form. By the time this long crisis ended, around 75% of all species on Earth had gone extinct in a slow, mass extinction like the first one we saw. The next one, however, is radically different. Permian-Triassic. 252 million years ago, life on land had really taken hold. This was long before the dinosaurs. Instead, the land was ruled by strange, reptile-like creatures, some looking almost like a cross between a lizard and a mammal. One of the most well-known was Dimetrodon's cousin group, the therapsids, which included animals that would eventually give rise to actual mammals millions of years later. For a while, things seemed stable, but then, in what is now Siberia, something started happening deep underground. Massive cracks in the Earth's crust began releasing enormous amounts of lava, not from one volcano, but from huge, long-lasting eruptions spread across a massive area. For years, there was an almost constant release of lava and gas, covering an area roughly the size of Europe. As this lava poured out, it released huge amounts of carbon dioxide into the atmosphere. This caused global temperatures to rise sharply, warming up the planet, and the oceans absorbed much of this excess carbon dioxide, which made the water more acidic, similar to how soda becomes acidic from dissolved carbon dioxide. This made it incredibly difficult for many sea creatures to survive, especially ones with shells or skeletons made of calcium, since the acidic water made it harder for them to build and maintain their shells. At the same time, rising temperatures caused oxygen levels in the oceans to drop, similar to what happened during the previous extinction, but on a much larger and more intense scale. Huge sections of the ocean became low in oxygen or completely lifeless. On land, extreme heat and unstable climates made survival difficult for plants and animals alike. Deserts expanded, and many regions became too hot and dry for their inhabitants. All of this caused a collapse of ecosystems across the entire planet, both in the water and on land. Many species that had survived earlier extinctions, adapting and evolving over millions of years, couldn't survive this one, and by the end of this event, around 90 to 96% of all species on Earth had disappeared. This makes it by far the most severe extinction in Earth's entire history, so much so that scientists often call it simply the Great Dying. Life on Earth came close to being wiped out almost entirely. Unlike previous extinctions, where ecosystems bounced back relatively quickly, it took millions of years for biodiversity to rebuild after this one. When life did recover, however, it eventually gave rise to entirely new groups of animals. Triassic-Jurassic. 201 million years ago, Earth was slowly filling back up with new forms of life. Finally, for the first time in history, the very first dinosaurs were there. However, they were still small and not yet in charge, because reptiles had taken over as the dominant animals on land, but not the reptiles most people picture. Large crocodile-like reptiles called pseudosuchians walked the land, some standing upright on two legs. All the continents were joined together into one giant landmass called Pangaea, meaning animals could wander freely across what are now completely separate parts of the world. This, however, would eventually cause a catastrophe. Deep underground, pressure started building again. Pangaea was beginning to split apart, and as it tore itself in two, magma pushed up through massive cracks in the crust, similar to what happened at the end of the Permian, but on a different scale. This event is known as the Central Atlantic Magmatic Province, and it triggered an enormous amount of volcanic activity across a huge stretch of the planet, right along the lines where the continents were beginning to separate. As lava poured out over what would eventually become the Atlantic Ocean region, it once more released massive amounts of carbon dioxide into the atmosphere, causing global temperatures to spike once more and setting up the same chain reaction as the previous mass extinction event, both on sea and land. The pseudosuchians that had been doing so well were hit especially hard. Many of them were larger, needed more food, and could not handle the sudden climate instability as easily as smaller, more adaptable animals could. One by one, entire groups of them disappeared. Meanwhile, something unexpected happened. The dinosaurs, which had been small and overlooked up until this point, managed to survive. Nobody knows exactly why dinosaurs made it through when so many others didn't, but a few things likely helped. They may have had warm-blooded bodies that kept them alive through sudden, freezing volcanic winters. Some may have grown up quickly, and their agile body types may have handled the climate shifts better than heavier, slower-moving animals could. Whatever the reason, when the disaster was over, the dinosaurs were suddenly one of the few large animal groups left standing. By the end of this extinction, around 76% of species on Earth had died out. With so many of their competitors gone, the path was finally clear, leading to the next era, which is, in my opinion, the most interesting one, both in terms of the period itself and the mass extinction event that followed it. Cretaceous-Paleogene. 66 million years ago, Earth finally belonged to the dinosaurs. Triceratops grazed in herds across what is now North America, and Tyrannosaurus rex, one of the largest land predators to ever exist, hunted along the coastlines. In the skies above, there were giant flying reptiles called pterosaurs, with wings that could stretch wider than a small airplane. In the oceans, there were massive marine reptiles, such as the Mosasaurus, a giant marine lizard that could reach up to a staggering 42 feet in length. Life was thriving and diverse for millions of years. Then, on what was just another ordinary day, somewhere, a group of Triceratops lifted their heads at a sound in the distance. After a bit, far above the atmosphere, something appeared that had never been there before. A tiny point of light, sharper than any star, hanging in the daytime sky. At first, it didn't move much at all, but slowly, hour by hour, it grew brighter and bigger. It kept growing, and what had been a faint pin of light became a visible glow, then a streak, then a huge ball of light. Animals across the land began to pause. Some lifted their heads toward the sky. Then it happened. In a matter of seconds, it tore through the atmosphere. It was an asteroid, roughly 6 to 9 miles wide. It slammed into the shallow waters near what is now the coast of Mexico, at a place we now call Chicxulub. The impact released energy equivalent to billions of nuclear bombs all at once. In an instant, everything within hundreds of miles was gone. Trees flattened and rock vaporized as the shockwave moved outward. Within minutes, a wave of heat swept across entire continents, igniting forests thousands of miles away. Animals that had been calmly grazing moments before had no time to understand what was happening. The impact threw so much dust, ash, and debris into the sky that sunlight was blocked out across most of the planet, and it stayed that way for months, maybe years. Without sunlight, plants died, and without plants, the animals that ate them starved. Without those animals, the predators that hunted them died off too. The world went dark, cold, and silent. Dinosaurs, which had ruled the planet for over 150 million years, could not adapt to a world that changed within a single afternoon. By the time the dust settled and the skies cleared, around 75% of all species on Earth were gone. Every single non-bird dinosaur had vanished completely. However, in the wreckage, small, unnoticed creatures survived. Tiny mammals, some no bigger than a rat, had been hiding in burrows. With their giant competitors gone, these small survivors finally had room to grow and spread. One single point of light in the sky had ended one era and started the path toward our own. If you want to discuss this video or suggest an idea for the next one, join my Discord, link in the description.